Hello there, random smart person on the internet. If you live on Earth, which I assume most of you do, the actual time for Earth to complete one full rotation on its axis is 23 hours, 56 minutes, and 4 seconds. This is known as a sidereal day. Even though the Earth has completed one rotation on its axis, since it's moving around the sun, it is not facing the same exact spot on the sun at the end of the sidereal day. It takes 4 additional minutes for the Earth to complete 1 additional degree of rotation, so the Earth is pointed directly at the same spot of the sun. But what happens if you're on a celestial body that has a different gravitational pull? Would one sidereal Earth day equal the same amount of time? Today we're exploring that important topic of timekeeping and its crucial role in space exploration, specifically for the missions to the moon. One of the most fascinating and puzzling aspects of the universe is how time doesn't pass at the same rate for everyone. This is affected by gravity and speed. For example, time moves a little faster on top of a mountain compared to a valley. While this difference is too small to notice in our everyday lives, it becomes important when we think about exploring space and living on the moon. On the moon, an Earth day is about 56 microseconds shorter than a day on Earth. Even though this seems very, very tiny, over a long period of time, these differences can add up and cause big problems. NASA and its international partners are working on this issue. Instead of just setting up time zones for the moon like we have on Earth, the goal is to create a new timescale that considers how time moves faster on the lunar surface. The plan is to develop a way to track time that works specifically for the moon, making sure all spacefaring nations are on the same page. The White House has asked NASA to come up with a detailed plan for this lunar timescale by the end of 2024 and to start using it by 2026, when astronauts are expected to return to the moon. Although if you know anything about space missions, it will probably be delayed to even longer than that. The next few years are important for improving how we keep time on the moon and figuring out how to set up and sync lunar clocks. Accurate timekeeping is essential for future lunar missions. Astronauts will need precise time for activities outside their spacecraft, scientific research, communications, and navigating lunar rovers. Throughout history, humans have relied on sundials and stone formations to keep track of time. Since mechanical clocks were invented in the 14th century, we have been striving for more precision. In the early 20th century, Albert Einstein's theories of special and general relativity showed us that speed and gravity slows time down. This explained why time moves slower at lower elevations where gravity is stronger. To handle these differences, scientists have set up atomic clocks in various places around the world. These highly accurate clocks use atomic vibrations to measure time. Clocks closer to the surface of the Earth tick more slowly. The combined readings for these clocks give us Coordinated Universal Time, UTC, which sometimes gets adjusted with leap seconds to match Earth's rotation. In space, time behaves even more strangely. According to special relativity, time slows down at higher speeds. For example, astronauts in the International Space Station experience a balance between slowing of time due to their high speeds and their reduced gravity, which allows their clocks to stay in sync with Earth time. However, for missions further out in space, it gets more complicated. Scientists have a lot of experience dealing with these challenges. Spacecraft have internal clocks called oscillators, which keeps time on their own while syncing with other control centers on Earth. For deep space missions, accurate timekeeping is crucial for navigating and planning. Studying atomic clocks on GPS satellites, which orbits Earth around 20,200 kilometers, or 12,550 miles above the Earth's surface if we're using freedom units, helps us understand how to establish a lunar timescale. The goal is to measure time on the moon accurately and make sure it matches with time on Earth. Setting up precise clocks on the moon is essential. There are discussions about funding, choosing the right clock, and where to place them. Atomic clocks are preferred for their long-term accuracy, while crystal oscillators are better for short-term precision. A network of lunar clocks will work together, similar to atomic clocks for UTC on Earth. This new lunar timescale will be part of LunaNet, a framework of standards for lunar missions. International collaboration is key, and discussions so far have been promising. It's unclear if countries like China will join in, but these talks will happen throughout the international standard-setting organizations. Accurate timekeeping is not only important for scientific research, but also for setting up infrastructure needed for lunar missions. What we learn from timekeeping on the moon will help us for future missions to Mars and other parts of space. So there you have it. You learned about how time differs on the moon and why it is important to have a lunar timescale. Leave a comment down below on if you knew that time moved differently at different locations. Comments are good for the YouTube algorithm. It really is. If you want to learn more about a future NASA mission I will be a part of, click on the video right here. Or, if you would like to learn more about the solar flare that hit Earth in February of 2024, click on the video right here. And always remember, have fun with STEM.